How does IFFT work in digital signal processing? Imagine you have a complex puzzle made of many tiny pieces. Now, think about how you can put those pieces together to see the full picture. That's kind of what the inverse fast Fourier transform does in digital signal processing. In digital signal processing, signals are often broken down into their basic parts using the fast Fourier transform. This process turns a time-based signal into a collection of frequencies, making it easier to analyze. But sometimes, you need to go back and see the original signal in the time domain. That's where the inverse fast Fourier transform comes in. The IFFT takes the frequency data and rebuilds the original signal. It does this by summing sinusoidal waves, which are like the building blocks of any waveform. Each of these waves is scaled by the complex numbers from the frequency spectrum. Think of it as adding together different musical notes to recreate a sound. Mathematically, the IFFT is very similar to the FFT, but with a few key differences. It uses the same algorithm structure but with a change in the sign of the exponent in its calculations. It also includes a normalization factor, which adjusts the amplitude to match the original signal. This process makes the IFFT very efficient, reducing the number of calculations needed from a very high number to a manageable one. In practical terms, the IFFT is used in many areas like wireless communications, digital audio, and image processing. For example, in modern wireless systems such as fifth-generation mobile networks, the IFFT helps generate the time domain signals from data symbols in the frequency domain. This is essential for transmitting data quickly and reliably. From an electrical engineering point of view, the IFFT helps reconstruct signals from their frequency components. It uses properties of complex conjugate symmetry to speed up calculations when dealing with real signals. The output is usually complex, but for real signals, the imaginary parts are very small and often negligible. The IFFT allows engineers to process signals in the frequency domain and then convert them back to the time domain efficiently. This makes it a vital tool in controlling systems, digital filtering, and signal modulation. Without it, working with signals in the digital world would be much more complicated and slower. In summary, the IFFT is the key that unlocks the original signal from its frequency spectrum. It uses a clever algorithm that is both fast and effective, making it possible to analyze, modify, and transmit signals in many modern electronic systems.